Okay, guys, 9.5. Remember, we did 9.4 rather than 9.5 on the schedule. I switched 9.4 and 9.5. But anyways, 9.5 is nonlinear systems of equations. And to solve these, it works a lot of the same ways as the linear equations, except for, if they're nonlinear, then maybe one of them isn't a line, or maybe both of them aren't just a single line. What does that mean? That means we can have more than just one intersection point, okay? So, two main methods for solving. This is what I'm going to stick with. I'm going to show you an example of each. Pretty self-explanatory. If you're good with the linear equations, this shouldn't be too much of a stretch. So the first method is, of course, substitution. And this is useful when one of the equations in the system is linear. That's the first type that we'll look at. In fact, it's this one right here. The second type of method is elimination, which we're also familiar with. This is generally more useful when both of the equations in the system are nonlinear, and that's what we're going to do for our second problem here. Okay, so just a few quick examples. Part A, x squared plus y equals 2 and x minus y equals 0. So before I start this, I'm going to do the algebraic method, but then we're also going to look at the graph of this, because remember what it means graphically. It's where these, I guess not necessarily lines, but where the graphs of these guys are crossing. Okay, so if I'm looking at this one, okay, one of them is linear. So in that case, I'm going to go ahead and I'm going to use substitution. So I could say something like this right here, okay? And to make a substitution, this looks like a pretty natural substitution. I can get everything in terms of x, okay? So really, nothing really new from when these were linear, okay? Now, if I go down, I can think of this as x squared plus, now I'm going to call this x, with the substitution I'm making, is equal to 2, okay? Now here's where there might be a little more work than the linear equations. The linear equations are usually easy. You just get x or y by itself. Here we have to remember how to solve a quadratic. And usually what I want to do is get equal to 0, and then I have different methods. Hopefully factoring works, right? So that's what I'll do. This is now x squared plus x minus 2 is equal to 0. So notice I'm just working with the first equation here. Okay, I use the substitution on the second. Now I'm working with the first. From here, I think I can factor. Okay, so this is going to be x, and I believe plus 2 and minus 1 should get me where I want to be. Okay, so now I know, of course, I have two possible solutions here. I have x equal to negative 2, and I have x equal to 1. Okay, well, if there's two possible values for x's, then I should probably find their corresponding y solutions, right? So if x is negative 2, then what's y going to be? So to do that, what I'll do is I'll just substitute into one of the equations. I think the second equation is easy. In fact, I'll give these numbers here, equation 1 and equation 2. So if I go into equation 2 and I use x equal to negative 2, I have negative 2 minus y is equal to 0. Notice I just took my x value that I had solved for and I plugged it in where I saw x in equation 2. You could just as easily use equation 1 if you wanted. And if I add y to both sides, I get negative 2 is equal to y. Okay? So if I kind of separate these, I see, oh, hey, I have a solution here. It's negative 2 comma negative 2. Okay? So there's one of my solutions. Okay, and you can plug this into the first equation, see that it does satisfy that as well. You can check these just like the linear ones. Now, if x is equal to 1 and I go into equation 2, this means that 1 minus y equals 0. Okay, well, that's not so bad. That means 1 is equal to y. So when x is 1, y is 1. So my solution there is 1 comma 1. So notice I have two solutions, and that makes sense because one of these is nonlinear. That won't always be that way, but it's very possible. So what I did is I actually got a graph of these two. Okay, so there's my solutions, negative 2, and 1, 1. And here is the graph of these guys. Okay. Now this green one, that's the nonlinear one. If you rearrange it around, okay, this x squared plus y equals 2. Okay, if I take that one, so the one in green, x squared plus y is equal to 2. It's fairly easy to see where they're getting that graph. That's done with transformations in this case, negative x squared plus 2, right? Negative x squared, I know it's opening down and it got shifted 2 up. That's the green one. The other one is just y equals x, right? Or x minus y equals 0. And you can see where they intersect. It's right at those points, right at those solutions. So always remember graphically what this means, okay? So that's the first one linear, one nonlinear, okay? Let's look at how we can solve one when they're both nonlinear. So something like this. Both are nonlinear. I do happen to recognize that the top one is a circle of radius square root of 10. But the second one, I don't think you've necessarily seen that before. Maybe, okay? So since these are both nonlinear, I'm going to use elimination. Well, elimination in this case is pretty easy because I can just add, my y's are going to cancel. Now, remember with some of these, you might have to scale them, and you can do that just like we did in the linear case, okay? So this will give me 3x squared is equal to 27, right? If I add these. And if I divide both sides by 3, I get x squared is equal to 9. And we know how to solve this. We can take the square root of both sides. But what's the important thing we have to remember? Well, we need to remember that it could be negative 3 or 3, right? We need to remember our plus or minus when we take the square roots, okay? So once again, I have to split these off, and I got to ask myself, okay, well, what about when x is negative 3, and what about when it's 3? Well, I guess I'll go ahead and I'll use the first equation, okay? So first equation, second equation. So if I use the first equation, okay, I have negative 3 squared. Remember, that's just the x I just found. I'm just plugging it into the first equation. Plus y squared is equal to 10, meaning 9 plus y squared equals 10. Y squared is equal to 1 if I subtract 9 from both sides. Well, if I take square roots of both sides, I get y equals plus or minus 1, right? Because we need the plus or minus when we take our square roots. So here, just from this side, with the x equal to negative 3, I have two solutions. I have negative 3, negative 1, and negative 3, comma, positive 1. So I got two solutions out of that. Let's see what I get from x equal to 3. So once again, using equation 1 from above, 3 squared plus y squared equals 10. You can see that it's kind of the same exact story as on the other side, right? Because of that squaring. Y squared equals 1. So once again, y equals plus or minus 1. So when x is equal to 3, we got two y values, okay? So from here, I guess I'll just kind of add them to what I got going on over here. I got 3 comma negative 1 and 3 comma 1. I have 4 solutions to this system. Are the graphs really intersecting in that many places? Well, one good way to check is bust out your calculator. Okay? So I took the liberty of graphing these things. And what you'll see is this green circle, that's the first equation, right? X squared plus y squared equals 10. Okay? Now this orange one, that's the other one. That's the 2x squared minus y squared equals 17. We haven't covered that. That's actually a shape conic section you would cover in pre-calculus, the next class, okay? But essentially what it does is it goes off in each direction like this, and there's actually these asymptotes that they never cross, okay? That's called a hyperbola, okay? And you can see that there are 4 places at which they cross, okay? So that is 9.5 in a nutshell. If you find any extra tricky ones, generally just stick to the method of when one's nonlinear, well, another one is linear. I would stick to using substitution. If they're both nonlinear, elimination. But remember, if you find any others in the homework that are giving you trouble, please email me. Okay, I had someone do that over the break, and I got 2 similar examples up. Okay, alrighty.